Hey guys, and welcome to a brand new PSP GPU tutorial. This will be the last one in the series for a while. And this tutorial, we're going to be covering how to dynamically create tile maps and use texture atlases. This will also be applied to render things like fonts. As always, the source code is in the description, and there's also a pure sceGu implementation. So to start with the code that we have, I've pretty much kept the same code as the last tutorial. I just removed the sprites specifically and the camera stuff. That's pretty much all that I've removed from here. The other important change here is setting the GL ortho. The orthographic matrix should be 0480, 0272, -10, and 10. And this is just to set up our coordinate system in a nicer system that's basically one-to-one pixel mapped. So to start off, instead of loading perhaps hundreds or thousands of textures, what game developers have actually figured out is that it's way faster and way easier to create texture atlases. Not only with having to deal with like trying to load, hundreds of files, but also the fact that when you place them into VRAM, they're kind of just thrown in there in a random order, and reading from one to another may cause a lot of jumps, which is called fragmentation. And what would end up happening would be that you would have really poor performance when trying to go through a billion textures, whereas reading from one perhaps is way simpler. So a texture atlas is basically the solution where they've gridded together a bunch of different characters, or for example tiles, this is from Crosscraft, together onto a single texture, and then they're just selecting each individual one that they want to render. To do this, we use something called a texture atlas. So to create a texture atlas, all you need is the width and the height. And that's all you actually need to do to define a texture atlas. And basically, we're taking a very simple approach. There are much more complicated and perhaps more efficient ways to load up a texture map or a texture atlas, but this is just going to be a very simple example. If you've ever worked with like Mario sprites or Pokemon sprites or something like that, they also look very similar. So, basically, when we're using the texture atlas, all we need to do is extract the UV coordinates, so the actual texture coordinates, for any individual texture inside of this atlas. So to do this, we're going to create a function called getUVIndex, which will be getting the index from a texture atlas, and it'll take in a texture atlas and a buffer. And it will also have to take in the index which we're trying to gather. So we're going to have a row equals index divided by integer atlas. So we're going to do, so the current row is going to be the index divided by the atlas. The current column is going to be the index modulated by the atlas height, and then, or sorry, will also be modulated by the atlas width here. Sorry, and then we'll have float size x equals 1.0 divided by the atlas, or sorry, we don't need a floating point here, just the atlas width. Same thing will happen on the y for the size. And this gets our texture in terms of the relative size. So if I have a 16 by 16 map, 1 divided by 16 is the size. 1/16 in each direction is the size. So then we'll create a y value, which is going to be the floating point row times the size y. And then the same thing will be here for x, but except it's going to be column and it's going to be size x. Then to do the height is y plus size y. And then the width is x plus size x. So that will get us all of the four important parts, the four important vertices or areas that we'll need. So then we're going to use the buffer that we input here to actually set the floating point value. So buffer 0 is equal to x, buffer 1. Now you normally set this to xy, but in this case I'm actually going to be inverting the Y values just to make it look better. The reason for that is that it's based on the way that we've set up our texture coordinates. You're going to have to do it depending on how you've set this up. So in this mode, the 0 is the bottom left, but if you have 0 being the top left, you're going to have to do it, or you'll do it XY like this. So then we'll do 2, XY, and then we'll do 4 is going to be the width, and then Y. And then 6 is going to be the width and then the height. That's 7. There we go. That's all you need to do for getting a UV index. Obviously, if you're having issues with your application, try changing these around to properly reflect the behavior that you want in your app. So now let's get on to what a tile map is. A tile map is basically just a collection of tiles in space. They're basically all batched together, built, and then rendered together to save on performance. If you've tried running some of these demos and just tried putting in, drawing a sprite like 4,000 times, for example, it will run terribly. But if you have 4,000 sprites, but they're all built into one mesh in a tile map, it may run way better. And this is actually true. I had a Stardust Engine test a couple of years ago where it was comparing sprites versus tile maps, and tile maps we could handle about 4,000 animated sprites at 30 FPS, whereas it wouldn't even run if you tried that with sprites rather than tile maps. So to define a tile, which is in any individual part of this tile map, we're gonna actually have to do. It'll have position into X and Y. You could use float here as well, and then you'll need the texture index inside of the atlas. Given that I just said that, to actually define the tile map, we're going to have a floating point, X, Y. We're going to have a scale on the X and scale on the Y. We're going to have a integer for the width and the height. And then we're going to have texture atlas, which we needed, and the texture for that atlas. So technically you could combine texture atlas to have a pointer to texture as well, but that's kind of a irrelevant detail. We're going to have a tile pointer, and this is going to actually be the array, so this will be the tiles array. And then we'll have a mesh as well, because you need to render it to the screen. Creating the tile map is actually not that hard. We'll just do tile map pointer and create tile map. And what we need here is going to be a texture atlas. So we're going to need an atlas. We're going to need the texture as well. So texture pointer to X. And then we'll have a size X and a size Y. So the tile map pointer, tile map, is going to be equal to, tile map, is going to be equal to tile map pointer from malloc, size of the tile map. This isn't too bad. Then if tile map is null, so if tile map is null, we're just going to return null. And we're going to have to go through this entire process again. We're going to do the number of tiles. So we're going to do tile pointer, malloc, size of the tile, times the size X, and times the size Y to get all of the components that we'll need. If tile map tiles is null, then we're going to have to free the tile map, and then we're going to have to return null. And then we'll do the mesh. So the mesh is very similar as well. We'll use create mesh. And what we'll do here is we'll do size X times size Y times 4. This is going to be 4 vertices, and size X times size Y times 6 for the 6 indices. You can technically use, there's a special mode for the PSP for sprites specifically that allows you to set just 2 points to define a sprite. That might be something worth looking into if you're interested. And of course, if this fails, If this fails, we'll do free tilemap tiles and free the tilemap and return null. Cool. Now that that's done, one thing I can really recommend here is going to be just default setting all of your values. So we're going to use memset, and what we'll do here is we'll do tilemap mesh data 0, and it's going to be the size of the vertex times size x times size y. And then we'll do the indices. Except here it's going to be U16, or sorry, size of vertex, size x, size y, and then it has to be 4 vertices per, and then 6 here too for the U16. And then we'll do memset tilemap tiles also to 0, and this is going to be the size of each tile times size x times size y. And I believe that's everything. So this tilemap create should be fully fleshed out. We're going to do tilemap, we're going to do atlas equals atlas. We're going to do tilemap texture equals texture. So we'll set that up, and then they call it text. Yeah, sorry, text. Tilemap x equals 0, tilemap y is 0, tilemap width is equal to size x, tilemap height is size y, tilemap scale x is, we're going to do 16 pixels because that's the actual size of our textures, which looks very blurry until you get like super zoomed in here. And then scale y is also going to be 16. And then of course we'll return the tilemap. That was very verbose, but basically this is just completely setting all of these things to default values. So then we'll do void destroy tilemap. This will be the method we'll use to clean up our tilemaps. So we'll do destroy mesh, tilemap mesh. Then we'll do free the tilemap tiles, and then free the tilemap itself. That's all you need to do. And then finally we'll do the draw. And the draw is going to basically be the same thing that we did for sprite. So you're pretty much going to do GL matrix mode, GL model. We're going to then load the identity. We're then going to say vector 3 v equals x is tilemap x, y is tilemap y. Now you can add a layer to this as well. In this case, I'm not going to do it, but it's pretty much just add another int and make sure you initialize it. And then we'll do GLU translate to this vector v. We'll then do a second one. I'm just going to copy this for ease of use. And then if you do Control Alt here, you can do scale. You can if you do a Control Alt in Visual Studio, you can add as many lines as you want to edit simultaneously at once. So we'll call this v1, and then we'll do GLU scale, GLU scale. There we go. And then we'll put v1 in here. We'll bind the texture, so we're going to do tilemap texture. And then we'll draw the mesh. So tilemap mesh. Boom, got that. Cool. This is not really the hard part about tilemaps. The hardest part about tilemaps is actually going to be what we're doing next, which is building them. So this is going to be a function that you call ideally once for either number one, once for the full game, or once, in a blue moon. It shouldn't be something that you're calling in a hot loop all the time. Because if you are, you're going to end up killing yourself in performance, and you'll probably end up performing either the same or worse, depending for your rendering. So we'll do this build tilemap, and we'll use tilemap here. So building the tilemap is just going to end up setting all of the data in the mesh up correctly. So to do this, we're just going to do for int I is 0, I is less than the size, so tilemap width times tilemap height, and then increase the I value. We'll create a buffer, and we're going to pass this into get UV index. This will be the tilemap atlas. Then we'll have the buffer, and then we'll have the tilemap at and then we'll read into the tiles index or the tiles array at index I, and we'll use the texture index from that value to get our UVs. Oh, oops, there we go. And then we'll set up our texture X, or our tile X is going to be floating point tilemap tiles at I.x. The Y is going to be similar. And then for size here, I'm just going to do 1 because it's integer based for now. But if you wanted, you could set this as a custom size as well. You could have tile scale X or whatever as your units that you use. So ty equals 1.0. And then we'll have to do a vertex pointer. We'll have to do a vertex pointer here. Tilemap mesh data. And then I'm going to copy this 4 lines. We can edit it. So we're going to have data in here, and it's going to be I times 4 because there's 4 vertices. And then for each index, we're going to have to march this array by 4. And then plus 0, that's temporary for now. And then we'll do create vert. And basically, we're going to do buffer 0, buffer 1. And then we'll have the color for now is white. You can actually add a custom color if you really wanted to as well. So then we'll have tx, ty, and then 0.0. And then, of course, I'm going to go through each one. So 0, 1, 2, 3 as the indices here. So 0, 1, 2, 4, 6, and then 3, 5, 7. 7. So tx, ty, tx, th. And then TW here and TW here. And then we'll have 0 as the Z value. And this looks good. Next one will then be tilemap mesh at indices. And then copy that 6 times. Oops. I times 6 plus temporary value. And each one has to be I times 4 here because you're actually referring into the array of vertices. This is really important. I did spend a lot of time fixing a bug that had to do with that in a different game engine. So just make sure that your indices actually refer to indices inside of here. So 0, 1, 2, 2, 3, 0 is the values here. And then this is just 1, 2, 3, 4, 5. And then at the end of this, of course, you're going to have to do SEE, kernel, dcache, write back and validate all. And that will make sure that your mesh is actually properly set. This is a pretty expensive operation, but given the fact that we can have very large tile maps, it makes sense to do it. So now that we've created our tile maps, let's actually end up using them. So first off, we're going to have to define a texture atlas. In this case, we're going to use one atlas because both of these texture atlases that I have are 16 by 16, so you can use that. And then we're going to do tilemap pointer, tilemap equals create tilemap. Then I'm going to center it. Tile atlas, we're going to put in the texture, and then I'm just going to do an 8 by 8 map here, and you can customize whatever size you want it to be. So the X, center it to 176, and then the Y to 136. And then what we'll do, we need to fill out the data before we build it. So if we do build tile map here, the tile map, it's not going to do anything. So we're going to actually have to fill the data here. So I'm just going to do for int y equals 0, y is less than 8, and y equals plus. Same thing here for x. This is technically an ambiguously enclosed loop, but it's fine. So we're going to define a tile. And then we say x is x, y is y, and then texture index is equal to x plus y times 8, and that will just be the total index value. And then we'll say tilemaps at tiles x plus y times 8 equals tile. So that way we'll generate all 64 tiles, and then we'll place it into the tile map. To make sure to draw it, we're going to do draw tile map, and then at the end here we'll just do a destroy tile map. I've noticed it's taking a little while now, but yeah, as you can see when we run our eboot, you see the tile map show up here with a selection of different images from our tile map that we had earlier. So now that you see that's working, let's go ahead and actually extend this a bit. So we can actually do tile maps for font rendering. So in default.png here, we have this bitmap font here, and basically you have everything in ASCII order. So at index 32 is 0, this is 0, 8, 16, 24 is 0, and then for basically every character, it's mapped identically to the way that ASCII characters would be mapped. So you can actually go ahead and just use those indices based on the actual character value from a string. So if we create a method here called drawText, and all this is going to do is it's going to set up our tile map here to contain the indices to the correct values. So we'll get the length, which is string length of str, and then for int I equals 0, I is less than length, and I equals plus. Ideally this is size t, but the t tiles at I is going to be equal to a tile. We'll have character c, which is just going to be the character that we get from the string. And then we'll define a tile dot x. You can set up any scheme you want here. You can do dot x equals I. The other option you can do is like dot y equals something else. You could do something like this, text index equals c. And this would render everything in a line. So we're going to go ahead and create a second tile map here, tile map 2. And we'll use the second texture. And then we'll do tile map 2. Tile map 2. X is going to be equal to 144. And then we'll do tile map Y 16. So this will be at the bottom of the screen. Then we'll just call draw text. So we'll say tilemap 2, and then we'll just do hello world as our default string here, and then we can call build tilemap and tilemap 2. Make sure to then to destroy the tilemap 2, and then to draw it as well. And there we go. We should be good to draw a font on the screen. And as you can see at the bottom, you see the hello world shows up. Now, you're going to have an issue here because there's a thing called kerning, which is the space in between that. I have developed solutions for this before. Basically, you're going to have to figure out how the spacing between each individual one works. And the best way to do that is just to read into the texture and just raw read the data to figure out what's going on and what you should do. That's my advice, at least. That's probably going to be the easier way of figuring out font kerning. It'll have to be automatic. Now, for loading fonts, actual fonts usually have kerning values like specified inside of them. So you could get something simpler like that, although perhaps it may not fit into your solution as elegantly because you're going to have to deal with loading entire font files. Either way, this is going to be the end of this tutorial. Congratulations! You've now made a tile map that can be used in your application, including using it for maps and text. This will be marking the end of the tutorial series, as I said earlier, but later on I do plan to create a more advanced series for things like lighting, shadows, rendering textures, and more. So thank you guys for watching, sticking with this tutorial, and have a great day.